we're going to talk through some changes to the graphs of the tangent and cotangent functions based off of the equations. So we're not actually going to do any graphing. We're going to look at the equations and talk about how the graphs would be changed. Understanding that is a key component to graphing. So first, we're focusing on the tangent and the cotangent graphs. The basic equation of those looks the same. We're going to have y equals a tangent of bx or y equals a cotangent of bx. Important to recognize a, similar to sine and cosine, where a is the amplitude. It's kind of the same here, where it's the coefficient of the trigonometric function, and it's going to be the stretch of that function. B on the inside with x, again, is going to be dealing with our period. So let's jump into that. The period of the tangent and cotangent, which you may already know, well, a normal tangent function has a period of pi. So if we have a value of b, it's going to alter our period. So now our period is going to be pi divided by b. So we might have to adjust that. And again, that a value is going to represent the stretch. So let's look at some examples and see what happens here. So we have the equation of y equals the tangent of 2/3 x. Now we know what a normal tangent function looks like. Great, love this for us. How is this going to be different? Well, the two things we need to consider are a and b. Well, we can see clearly that the coefficient of this trigonometric function is 1. So if a is 1, that doesn't change anything. We are not stretching or shrinking or anything like that. It's going to have our normal flow. The difference comes in that we have a b value of 2/3. So that means we are going to want to find our period, and we know that, again, our period is pi divided by b. So I'm going to take pi divided by 2/3, and just walking through the dividing of fractions, pi divided by a fraction. Well, how do we divide by fractions? We multiply by the reciprocal. So if I take pi times 3/2, that's the same as 3 pi over 2. So our one revolution of our tangent function basically is going to happen over a period of 3 pi over 2. So if we think about, I'm not doing an actual graph, but if you think about this, we know that our tangent function starts at 0, 0. So that means if our period is 3 pi over 2, that means half of it's going this way and half of it's going this way. So how does that change our vertical asymptotes? Well, half of it goes to the right. So what is half of 3 pi over 2? Well, that's 3 pi over 4. So this asymptote would be at 3 pi over 4, and then the left asymptote would be negative 3 pi over 4. So that would give you just kind of an idea of why are we doing this? How is this going to help what we're doing now? All right, let's look at the next one. We have negative 3 tangent half x. Man, there's so much going on with this one. First, we know that we have an a value of 3, right? So a is going to be 3, which means we have a stretch. Think about like the amplitude with sine and cosine. It's that same idea that instead of just being at 0, 1, for instance, we'd be at 0, 3. So it's a stretch. We have a b value of 1/2. So once again, we find our period. Our period is going to be pi divided by 1/2. Well, if I have pi divided by 1/2, that's the same as pi times 2. So my period is going to be 2 pi. So if you think about what a normal tangent function looks like, how it's, maybe tall and skinny, well, now you're going to take that thing and you're going to make it over 2 pi, so it's going to be a little bit flatter, a little bit because of that 2 pi piece. Now that's 2 pieces, and then we have that negative. So don't forget that the negative is going to reflect across the axis. So reflection across the x-axis. Now, this one, I am going to just kind of give you a basic thought process here. Our normal tangent, right, is this. Well, if you think about, if I flip it across the x-axis, it goes this way, right? So this is the negative tangent. And you might be thinking right now, that looks an awful lot like cotangent. Yeah, sure does, because that's what it's a flip, right? So when you flip the tangent, it's very much the cotangent. But that's the idea that you got to think about. when you have that negative, you're going to flip it across the axis. So those are the three big pieces from this equation. Let's look at y equals 1/2 cotangent of 2x. Okay, well, no problem here. We see that a has a value of 1/2. So again, we're going to have, just thinking about if normally we're at 1 and -1, well, now instead of, going this way, well, now you're going to be here. So it might just change it a little, right? That's all the 1/2 does. It just changes those points a little bit. Not too big of a deal. We do have a b value of 2. So the period is going to give us pi divided by 2. Okay, great. There's nothing to do with that. It's just pi divided by 2. So now instead of having a period of pi, we're shrinking that in half, right? Cutting the period in half. You'll notice it does not matter that this is a cotangent versus a tangent. Cotangent and tangent functions are worked the same in terms of how this looks. So we know that cotangent generally, goes down this way, and that's how it's going to be. So the only difference is instead of this being pi, this is going to be pi over 2 because we're changing that kind of piece a little bit. But just remember that cotangent is decreasing on the intervals. Y equals 2 plus tangent of x. Hopefully you're like, oh, tangent of x, that's like the normal. Yep, sure is. And then we have this plus 2 out here. So that tells us we're going to take the normal tangent of x and move it up 2. So if we think about our normal tangent, that is here, and then this is at 1, and this is at -1, and it goes up this way, right? This is the normal tangent. Well, if we're going to go up 2, okay, well, so this comes up here, this one goes up here, and this one comes here. Just right? The asymptotes don't change. It's just the graph of it that changes. So the whole point of this is being able to look at these equations and understand how it manipulates the graph. Notice how the graphs that I've jotted down on here are not beautiful. They're not going to win any awards, but they're enough that I understand what it should look like. And that's the goal that we're shooting for here. All right, last one. Y equals -2 minus the cotangent of x minus pi over 4. Whew. So this one, we are going to go down 2 because of that -2 out yonder. Inside with x, we have a negative pi over 4, which means we are going to move right pi over 4. And you'll notice that our cotangent has a negative, so that negative in front of it is going to reflect across the x-axis. So it is important that you pay attention to the different pieces that you see and make sure you have them all accounted for as you're going.